This is the Math 236 calculus for the business and the social science. Today we will learn Chapter 4. The topic of Chapter 4 is application of derivative. And we will talk about the examples for Chapter 4, homework. Examples of Chapter 4, homework. First question, the profit function of Acrosonic Company is given by P means profit, P of X. X is the number of Acrosonic model F loudspeaker systems. How many X loudspeaker systems produced? Profit in terms of X is negative 0.02 X squared plus 4X minus $300,000. And find where the profit function is increasing and where it is decreasing. To determine if the function is increasing, the first derivative. If the first derivative f(p) prime of x is positive, then the function is increasing. If the first derivative p prime is negative, the function is decreasing. The first derivative is defined by the slope. For example, if a function like this, the graph like this, at this point, slope at that point uses slope at this point is f prime of x. The definition is limit h approach to 0, f of x plus h minus f of x over x plus h minus x. X minus x cancel, so denominator is h. That's the slope formula. So from this point, this is first of all we find out the secant line slope. Then when the point is approach to this x point, then that's secant line slope. Gradually approach and get secant line slope. And gradually when h very close to 0, almost 0, that's become a tangent line. So then the limit of this, of the slope, it's we define equal f prime first derivative at point x. This point is x f of x. So if positive, then the line rise up because numerator is positive, because here is x, this is x plus h, and the point over here on the curve is higher, is larger than, so the difference is positive. And then this point x plus h minus x, this is h, also positive, divided is positive. So the curve go like this, increasing. This is increasing from left to the right. The y value go larger and larger. When x go larger and larger, the y go larger and larger. So this is increasing function. The first derivative is positive. And the other one, if a decreasing function, and then this and to this point is x f of x. Then first of all is a secant line, and this point is x plus h, f of x plus h. Then if you do subtraction, and you will see here f of x plus h minus f of x. This, it's a positive because this is higher than this, so it's a positive. And then this x plus h minus x. And since this one is less than x, this is less than x, which is h is negative. So the h go infinite, then positive over negative, slope is negative. That is the first derivative. So if a decreasing function from left to the right, the y value go lower and lower. Decreasing function, then the first derivative is a negative. So first derivative is a negative. The function is a decreasing. It's a decreasing function, which is the slope from left to right is a fall down to the right. The tangent line is a fall down to the right. This tangent line is a rise up. Rise up. So use this property. This we call here. This one is the notes of chapter 4. Increasing, decreasing test. If f prime of x positive for every value of x in an interval a to b, then f is increasing on the interval a to b. The second one, if the first derivative is negative for every value of x in the interval, open interval a to b, then f is decreasing on the open interval a to b. Now, if f prime of x equals 0 for every x in the interval a to b, and then f is constant on a to b, that means it is a horizontal line. So for this increasing, either concave up increasing or concave down increasing, then the f prime is always positive. Tangent line is a rise up. That's the first case. Second case, decreasing. The function is decreasing, concave up or concave down decreasing. The tangent line is a negative. Fall down to the right. Slope is a negative. And the third case is a constant. Then constant slope is equals 0. First derivative equals 0. Then the function is constant from interval a to b. Because constant take derivative is 0. So this we call increasing, decreasing test. So use this, we can do this question. Here, once you figure out the profit, where is increasing, where is decreasing. So you take the p prime of x equal negative 0.02 times 2, get negative 0.04 x 2 minus 1, so it's 1, x to the power 1, plus 400 times 1 is 400. X to the power 1 minus 1, that's x to the power 0, it's 1. So 400 times 1 is 400. Minus 300,000 take constant. Constant take derivative is 0. So this is the first derivative of profit function. Then let's try increasing. We let f prime of x greater than 0. Then the profit is increasing. So that's f prime of x is a negative 0.04 x plus 400 greater than 0. Solve for this. Solve for this, we move this term to the right. Then I change this negative, become positive on the right side, 0.04x. less than 400. Then divided both sides, we are isolate x, divide both sides by positive 0.04. So it's still same symbol, inequality, same, don't change. And this 400 divided by 0.04, you can, because here move to the right 2 positions, so become 4. And the 400 original point here, decimal point there, move to the right 2 positions, become here. So you add 2 more zeros and divide it, cancel 4. Cancel 4. Then and write x first. X first. So become x, this side, this pointer to x. So this side is smaller. So put less than. X is less, x this side. X is less than 10,000. 10,000. Then we put the final answer, and we have to put down the units like dollars, how many units of systems. So you will say when the produce less than 10,000 loudspeaker systems produced, the profit is increasing, because I put prime of x is greater than 0 and get x is less than 10,000 units. The profit is increasing. And in other hand, if f prime is less than 0, then profit is decreasing when x is more than. So when greater than 10,000 loudspeaker system produced, the profit is decreasing. That's the first question. Second question. The total sales S in thousands of dollars of Arctic Air Corporation, a manufacturer of automobile air conditioners, is related to the amount of money X also in thousands of dollars the company spends on advertising its products. By the formula, S is sales, X is the money spent advertising. So equal this function. Question asks you find the inflection point of S. What is the inflection point? How to find out the inflection point? And we will use the second derivative. Finding inflection point. So we use second derivative. We put f double prime of x, let f double prime of x equal 0. Now, if f double prime, change the sign from positive to negative or from negative to positive at C. Now, C is the solution of f double prime of x equals 0 at C. Then at C, function value is f of C, is an inflection point of f. That is we call, if f function change the concavity at C, then CF of C is an inflection point of f. I will come back to talk about inflection point later, because we need to learn more. Then we can talk about inflection point. We should talk about inflection point after we talk about concavity. So that's the 2 question. 2 and the 3 we talk about later. Now next one, we will talk about question 4. Question 4. Now we can talk about question 4 before question 2 and the 3. Question 4 is find the absolute maximum value and the absolute minimum value, if any, for the function given in this closed interval. So how to find absolute maximum, absolute minimum? Finding the absolute maximum and the minimum values of a continuous function f on a closed interval AB. Closed interval, we use bracket, including the 2 endpoint AB. Open interval is not include the 2 endpoints. Use parentheses for open interval. Not include the 2 endpoints AB. So first of all, determine the critical numbers of f in open interval AB. Use parentheses. And what is the critical number? Is for the continuous function, you just take the first derivative of f, get f prime of x, and let f prime of x equal 0. Solve for the x, and those x make first derivative equal 0. Those number we call critical number. We call critical numbers. And then find the function value of those critical numbers. Find if C is a critical number, you need to find f of C. Plug it into original function, get function value. The third one, find the values of f, function value, values of f, which is a function value, at the endpoints of the interval, closed interval AB. That means find out f of A and the f of B. And compare all the values found in step 2, the function value for the critical numbers and the function value for the endpoints. Compare those numbers, function values. The largest one we call absolute maximum value. The smallest one is the absolute minimum value. Now, let's try the question here. The question 4. Given this function, this is x squared minus 2x minus 3. Here the leading coefficient is a positive. And so this function is a parabola. Leading coefficient is positive, so it's a parabola open upward. A parabola open upward. And there is a vertex. Leading coefficient is a positive. The parabola is open upward. So how to do? First of all, we take first derivative f prime of x, which is 2 times 1 get 2, and the x2 minus 1 is x to the power 1, minus 2 times 1 is minus 2, x to the power 1 minus 1 is x to the power 0 is 1. Negative 2 times 1 is a negative 2. Minus 3 is constant, take derivative is 0. And let this first derivative equal 0. Let f prime of x equal 0. So that's let 2x minus 2 equal 0. And move 2 over, get 2, and divided by 2, so x equal 1. X equal 1. And you don't need to test is relative maximum or relative minimum. You don't need to do so. So, and you find out critical number. This 1 is critical number. Then you find out the f of 1 function value at when x equal 1. You find out the function value f of 1. Plug it in. X is 1. Plug in x. 1 squared minus 2 times 1 minus 3. So get 1 minus 2 minus 3 and get negative 4. That's a function value of critical number. Only one critical number. Then find out the function value for the endpoints when x equal -2. Plug in. -2 squared is a 4. Minus 2 times -2 is a plus 4 and minus 3. So it's a minus 3, got 5. Another endpoint 3. When x is 3, plug it in. 3 squared is 9. And minus 2 times 3 is 6. Minus 3 is a 0. It's a 0. Now compare those three values. The largest one is a 5. The smallest one is a -4. So 5 we call absolute maximum. -4 we call absolute minimum. So then we answer absolute maximum value is 5. Absolute minimum value is -4. Absolute maximum value is f of 1, so it's occurred at x equal 1, x equal -2. Absolute value, function value is -4 is for f of 1. So absolute minimum value occurred at when x equal 1. That function value f of 1 is -4. Then next one, similar to question 4. Find the absolute maximum value and the absolute minimum value if any of the function of this function. Now this function leading is a quadratic function, degree is 2. Leading coefficient is -1. So this, the graph is open downward. There's a vertex over there. So similar, first of all we find first derivative and that first derivative equals 0. Get critical points. And then find out function value of the critical number and find out the absolute value of endpoints. And compare those function value. The largest one we call absolute maximum, and the smallest one we call absolute minimum. So first of all, find out the f prime of x. F prime of x. So we'll get -1 times 2 is -2. X to the power 2 minus 1 is x to the power 1. Plus 4 times 1 is 4. X to the power 1 minus 1 is x to the power 0 is 1. So 4 times 1 is 4. 6 take derivative is 0. So we got this is the first derivative function. And that equals 0. So it's a -2x plus 4 equals 0. Then 2x move over, get 4 equal 2x divided by 2, both sides, get x equal 2. That's critical number. And find function value when x equal 2. So x use 2, substitute in, equal -2 squared minus 4 times 2 plus 6. 2 squared is a 4. In front have a negative sign. Negative sign. This one. -2 squared. Then -2 squared is different. -2 squared is -2 times 2. This equal -4. -2 squared base is -2 times -2. Negative times that become +4. That's a different. So this is a negative. Negative. 4 times 2 is 8 plus 6. And figure out is 10. And the then find out endpoint 0 and the 5 function value. F of 0. Substitute x in 0. Negative x is 0. X is 0. So the two terms are 0. Add 6. So equals 6. Then endpoints 5, f of 5, negative 5 squared plus 4 times 5 plus 6. Here again, negative 5 squared. Negative 5 squared means negative 1 times 5 squared. So equal negative 1 times 5 squared is 25. 5 times 5, 25. Negative times positive is negative 25. If I have parentheses, then that will be base is negative 5. So it's negative 5 times negative 5. Negative times negative become positive 25. So this one is a negative, so negative 25. 4 times 5 is 20, add 6. And the 26 minus 25 get 1. Then compare those value, function value, 10, 6, 1. The largest one is 10, it's the absolute maximum value. The smallest one is 1, we call absolute minimum value. Then put the final answer. Absolute maximum value is 10. Absolute minimum value is 1. So function value 10 occurred at x equal 2. Minimum value 1 occurred at x equal 5. Question 6. Ecosonic total profit in dollars from manufacturing and selling X units of their Model F loudspeaker system is given by, this is a profit function, P of X. It's similar to the first, is similar to first question. Profit function, same thing. This first question, profit. The sixth question again, profit. Now the first question we find out where the function is increasing, where the function is decreasing. And the question 6 is a continue question 1. Same function, same profit function. This one. Ask you how many units of loudspeaker system must Ecosonic produce to maximize its profit. So this function, you see, this is quadratic, degree is 2. Leading coefficient is negative 0.02. Those are coefficient. The highest exponent coefficient we call leading coefficient. This one is negative. If a negative leading coefficient is negative, the graph is open downward. Parabola is open downward. And here has a vertex, and this vertex is a maximum. It's a maximum, the highest point. So looking for what is how many units, which is x. X units. X is represented how many units are produced of the loudspeaker system. P means product, which is dollars. P is in dollars. Want to find out which X can produce to maximize the P, the product. In other words, you are looking for this vertex. This point is vertex X, P of X is highest point. The P of X value is the highest one. And looking for what is X, what this X coordinate make the product highest one. So in order to get we call relative maximum, you can use first derivative test and the second derivative test. Because if the function from left to the right, if increasing, the slope is positive, rise up. If increasing after this point and become decreasing. After that point, become decreasing. And that is a relative maximum. So then you have to find out first derivative test. To the left, a positive, to the right, negative, and then that's in that point, critical point, it's a relative maximum. Relative maximum. And the second derivative test is if you take second derivative at that point, it's a negative, then it's a relative maximum. So there it's a two kind test. You can use first derivative test. Suppose that c is a critical number, which is the first derivative equals 0. Solve for the x. C is a critical number of continuous function. So first of all, you find out critical number. You let first derivative equals 0. Solve for x. Those we call critical number. Then second one, if f prime changed from negative to positive, which is a negative, is a first derivative is slope of tangent line. Tangent line is fall down to the right, slope is negative. At this c, x is c, f of c, from negative, after this turning point, slope become positive, rise up. So it's from decreasing to increasing. Then this point is the relative minimum, also called local minimum. So f prime changed from negative slope, it's a negative tangent line fall down to the right. That's the first derivative. It's a negative, slope is negative, to positive at c. This point is a c, x is a c. Function value is y coordinate, it's f of c. Then f has a local minimum. Local minimum. If f prime changed, the third case, the third one changed from positive, you see this increasing, the first derivative is a positive, rise up, slope is a positive. Go after this turning point, after xc, f critical point, then go fall down to the right, fall down, slope is a negative. So from positive, so the slope change from positive to negative, or the function, original curve, function change from increasing to decreasing. The first derivative change from positive, which is the slope of tangent line, rise up, is positive slope, to negative, the tangent line, negative, fall down to the right, slope is negative. For the original function, the curve is from increasing change to decreasing. And this critical number is a relative maximum, also called local maximum at c. If it doesn't change the sign at c, if f prime is a positive on both sides, or positive or negative on both sides, doesn't change the sign, then f has no relative maximum or minimum at c. And this we call first derivative test. So there's another one. Let's talk about this concavity test. Is a second derivative. If a second derivative is a positive for every value of x in open interval AB, then the graph is concave upward. Concave upward, if increasing, concave upward, or decreasing, concave upward. This we call concave upward. And if a second derivative is negative, then the graph is like a decreasing concave downward or increasing concave downward or increasing concave downward. This we call concave downward. The curve go like this, go in the direction concave downward. This concave downward. This is up, concave upward. So first derivative is a positive, concave upward. A second derivative is positive, concave upward. Second derivative is a negative, then concave downward. That's a concavity. So what is the inflection point? Is the concavity changed, the sign changed. If f, you find if a second derivative equals 0, and the second derivative change the sign from positive to negative or from negative to positive. So that means if concavity from concave upward, then concave downward. Concave upward, second derivative is positive. Concave downward, second derivative is negative. And this concavity changed. Original function, the concavity at C, changed the concavity from concave upward to change to concave downward, or from concave downward and change to concave upward. And those we call point of inflection. Which is the second derivative sign changed from positive sign, changed from positive sign changed to negative sign, or from negative sign changed to positive sign. From positive change to negative, in other words, f function concave upward change to concave downward. That's point of inflection. From f double prime from negative change to positive, that means concavity change from downward change to upward. And this also point of inflections. So from here, we can get second derivative test. We compute first derivative and the second derivative. Find all the critical number of f. Let first derivative equal 0. And those solve for the x. Those number we call critical number. And those critical number c, and so compute second derivative at c. For each critical number c, you figure out f double prime of c. If f double prime of second derivative is a negative, then it is a relative maximum. Is relative maximum. This is concave downward. This point is relative maximum. This is concave upward. And this from this is a relative minimum. That's the second derivative test. For the first derivative, it's f prime changed from positive to negative. First derivative change from positive to negative. This is a relative maximum. For the second derivative test is if a double prime is a negative, and that is a relative maximum. For the first derivative test, if f prime change from negative to positive, then this is a relative minimum. For the second derivative, if second derivative double prime of c, if a positive, then this is a relative minimum. There's two tests. You can use either first test or second test to determine relative minimum and the relative maximum, also called local minimum, local maximum. So let's try this one. This one, you leading quadratic function and the leading coefficient is negative. So you can see has a maximum, relative maximum. So looking for what is the maximum profit. What is x make maximum profit? So you can use either first derivative test or second derivative test. First of all, you find the first derivative f prime of x and solve for the x and get 10,000. Now here I use second derivative test. I plug into second derivative, so I find second derivative f double prime of x, which is this. F prime take derivative again, get negative 0.04 times 1, and the 1 minus 1 is x to the power 0, so get is a negative 0.04. 400 is constant, take derivative is 0. So when 10,000 plug into the x function value is a constant, is a negative 0.04. Is a negative. Second derivative test. If the second derivative at that point is at that critical point, it's a negative. That's a relative maximum. So this is a relative maximum. Relative maximum. So the 10,000 units of Model F loudspeakers system can produced to maximize its profit. And that's I directly use second derivative test. You can use first derivative test is to the left, to the right, different sign. From the first question, you can see to the left, less than, the profit is increasing. First derivative is positive. When x is less than 10,000, that's to the left of 10,000. First derivative is positive, function is increasing. In other words, over 10,000, more than 10,000, the first derivative is negative. The function is decreasing. So at this point is a relative maximum. What is the maximum profit? So you got 10,000, then plug into original p function, got p of 10,000 equal negative 0.02 times x is 10,000 squared minus 400 times 10,000 minus 300,000. So this one is 4 zeros. Square become 8 0. 1, 2, 3, 4, 5, 6, 7, 8 zeros. And then times by negative 0.02. I should put negative 0.02 times 8 zeros. Now after times it will be what? So this should be 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4 square. 1, 2, 3, 4, 5, 6, 7, 8 zeros and 1 times by this net 0.02. And then this one, 1, 2, 3, 4, 5, 6. So I have 6 zeros. 1, 2, 3, 4, 5, 6. This one is 4 zeros. And the two times together will be move decimal point to the right 2 positions. Got 2. So it's time together, you got 2 and 8 zeros. And because here 2 decimal digits, so you cancel that 2 zeros. So you got 2 and 1, 2, 3, 4, 5, 6. 6 zeros. 2 and the negative. Add with this 4. also 6 zeros. Add together. This is a -2 with 6 zeros. This is a +4 with 6 zeros. Add together, you get 2 with 1, 2, 3, 4, 5, 6 zeros. The two terms combined is this 2 million and minus 3 with 1, 2, 3, 4, 5 zeros. And subtraction. 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. So this is 1, 2, 3, 4, 5, 6 minus 3, 1, 2, 3, 4, 5. Get 17, 5 zeros. 1, 2, 3, 4, 5, 6. Yeah, 17 with 5 zeros. So you will get 5 zeros. 1, 2, 3, 4, 5. And $1,700,000 is the maximum profit. You can use calculator to do. Now we can go back to question 2 and 3. Talk about the inflection points.